So, hello everyone. I'll be your reporter for today and I'll be opening the discussion tungkol sa polyphase transformer connections. So, familiar na sa atin yung mga tinatawag na single-phase transformers and various connections. Pero ano nga ba ang ibig sabihin ng polyphase transformer? Ano nga ba ito? So, here is a quick definition. So, what are polyphase transformers? These are transformers that are used to provide 3 or more phases. So, nandun na din sa pangalan niya, poly, meaning many, phase. So, yun siya, nakakatulong siya para makapag-provide ng 3 or more. According sa na-search ko, nabanggit nga na 3 or more phases, it can even elaborate combinations daw up to 24 phases para sa DC rectification transformers. But we will be focusing on the various uses nitong polyphase transformations na to and the first connection to be discussed, which is delta-delta connection. So, let's proceed. Here are some uses of polyphase transformations. So, according daw dito, low-voltage polyphase transmission lines are sometimes supplied directly from polyphase generators. And such systems daw is limited lang dun sa voltages of 6,600 volts up to 13,200 volts. And inherent yung voltage na yun sa mga generators. Inherent meaning permanent siya. To proceed, generators daw of higher voltage are subject to insulation difficulties. So, ibig sabihin na may na-experience siyang hirap when it comes to insulation. Aside from that, generators of higher voltage daw, yun na nga, is mas expensive and requires more coil insulation. For the next slide, it says here na ang economy in power transmission over long distances require the use of high voltages. So, we have 110,000 to 220,000 volts, merong 287,000 volts, etc. And usually, ang magnitude of transmission voltage is about 1,000 volts per mile. So, here, ang requirements daw for the transmission system, therefore, is parang nagiging necessity yung paggamit ng mga polyphase transformations between generators and transmission lines. Take note, ang high voltage is hindi magagamit directly dun sa load and therefore must be stepped down for utilization. So, yan. For the next slide, here. Meron daw special devices that require more phases than the 3 that are normally present on the transmission system. So, ito yung nakalagay dito na ang polyphase transformations daw is used to convert 3 to 6 phases for the supply to rotor converters, example to. And similarly, 12 phases can be produced from a 3-phase supply for rectifiers. So, tulad ng nabanggit ko kanina is, hindi lang siya limited for just 2 or 3. Maraming phases siya na pwedeng ma-produce. Here, it is also stated that 9 phases have been produced for special control circuits, and there is a possible conversion from 3 to 2 phases and vice versa. Continuing our discussion, magpo-proceed na tayo sa delta-delta connections. So, delta-delta connections daw is one of the most common 3-phase to 3-phase voltage transformations used on low voltages. And itong delta-delta connections daw is also used to supply loads that are primarily 3-phase, pero pwede din naman yung merong small single-phase component. And here, meron tayo ng representation ng delta-delta connection. Notes, sa delta-delta connection, ang primary voltages daw can be supplied when the secondaries, or in this case is itong part na to, denoted by letters A, B, C. A prime, B prime, and C prime. So, primary voltages daw can be supplied when the secondaries are open-circuited. So, ito naman yung sa primary. It is to be taken note of that care should be taken to make sure that the sum of the voltages is 0. If any of the windings are connected with improper polarity, then closing the delta will cause a short circuit on the system. Aside from that, yung load din naman dito can be connected in either Y or delta. Let's proceed. So here, meron tayong ng voltmeter. And according sa binigay din na reference, voltmeter reading should be 0 before closing the delta. Let's proceed to the next slide. So here is one example. So assume daw a 20 to 110 voltage transformation supplying 3 100 ampere loads at unity power factor. Exciting currents will be neglected. If a single phase load 1 is connected to the points AB, a current of 100 amperes I prime will be supplied from the secondaries. So yung connection na yun is represented by this here. So next. So let's continue. Here, makikita natin dito yung figures B, C, D, E, which are actually vector diagrams for current produced by single-phase loads, and here sa E, currents produced by balanced three-phase load. Continuing from the prior, here, if all transformers daw have equal impedance, only a portion of I prime will be supplied by each transformer secondary. Part of I prime will flow from A to B, and the remaining portion, this is B lang. And the remaining portion from A to C to B. The transformer impedance from A to B A to B is 1/2 of the impedance from A to C to B, and the drop in the voltage from A to B must equal the drop from A to C to B, since these two paths are parallel. So in short, eto siya. Yung I prime is equal to 100 amperes, which is nabanggit na dun sa problem kanina. Continuing from, yung IAB natin, here, we can see, is equal to 66 and 2/3 amperes, and IAC and ICB must equal 33 1/3 amperes. And makikita din natin dito na ang I prime is in time phase with the voltage VAB. So, ayan. The vector diagram of the secondary circuit for the single-phase load is shown. Ito na nga. And, based on sa mga vectors, I prime is equal to IAB plus ICB. Or basically, IAB na nabanggit dito na 66 and 2/3 ampere plus ICB, which is equal to 33 and 1/3 amperes. So, equal siya sa 100 amperes na nagko-correspond dito. So, tama. Also, IAB minus IBC. So, ulit lang yan, 66 2/3 amperes. But this time, since ang niya is minus IBC, therefore, itong 33 and 1/3 amperes na to will equal to negative 33 and 1/3. And this will also result to 100 amperes, which is, itong, is true. Same goes for this one. Going further, if another load to daw is connected between A and C, a current I double prime, so here, makikita natin dito, of the same, ng 100 amperes, will distribute itself in accordance with the relation shown in figure 65C. So, ito na nga. If load 2 is now connected to the winding CB, a current I triple prime will distribute itself as shown in figure 65D. So, sa 65D, ito siya. I triple prime dito. Dito makikita yon. If all loads daw are supplied simultaneously, the total current in any one winding of the secondary can be obtained by summing up the three components of current produced by each load in that winding. So, yun daw, the total current, therefore, IAB with all loads present will be IAB of figure 65, ito, IAB of figure 65C, dito, ito, plus IAB of figure 65D, which is, makikita natin dito. So, makikita natin sa vector diagram yung sum as shown IAB total. Here, makikita natin yun dito. Here, Continuing on, in a similar manner daw, the total currents in BC or IBCT and CA, ICAT can be obtained. It will be noted for these balanced loads, the currents in the transformer secondaries are equal to the load currents. This would not be true if the loads were unbalanced as to magnitude or as to power factor. However, the principle of obtaining the individual transformer currents would be the same as described above. Then, by Kirchhoff's law, the secondary line currents can be obtained since, dito na naman tayo ma-base, IA, by Kirchhoff's law, will be equal to I double prime minus I prime. IB is equal to, yan, IB is equal to I prime minus I triple prime. And IC will be equal to, here, nito siya, I triple prime minus I double prime. So let's proceed. The volt amperes delivered by the transformer bank is therefore, total VA is equal to VAB IAB plus VB IBC plus BCA ICA. Pero for a balanced load, magiging equal na lang siya lahat. Therefore, ang total VA din is magiging 3 VAB IAB. However, ang IAB daw, take note, is equal to IA over square root of 3. And since meron kang IAB dito sa total VA na to, ang mangyayari na is total VA will be equal to 3 VAB times IA all over square root of 3. Multiplying the said total VA here by square root of 3 over square root of 3 para matanggal yung radical sign will then result to square root of 3 V line I line. So, in the previous presentations of the single-phase transformer, naging common practice na daw na ang impedance drops or when impedance drops and exciting currents have been neglected to draw primary currents 180 degree out of time phase with a secondary terminal voltage. Applying this principle with due regard to turns ratio, the primary vector diagram can now be constructed as shown in figure 66. So, makikita na lang yun for the next slide. Then, the primary line currents can be obtained by applying Kirchhoff's law, which will be shown here in the next slide. Yan. Primary line currents can be obtained by applying Kirchhoff's law. Here naman, ito na yung magiging figure na pagbabasehan. Nandito. Yan. So, by Kirchhoff's law, again, we will have I1 is equal to I12 minus I31. I2 is equal to I23 minus I12. And I3 is equal to I31 minus I23. So here, it should be remembered now that the direction of the currents I1, I2, and I3, and likewise yung IA, IB, and IC na nakuha natin previously as indicated on the circuit diagram are not the instantaneous directions of the currents. Polarity lang. They indicate the directions of the currents when they are positive. So for loads of unity power naman daw, the phase voltage and current are in time phase. Pero hindi ito true or nag-a-apply for line voltages and line currents. So dyan po magtatapos ang aking presentation. Thank you very much for listening. Please do take note of these following formulas. Thank you very much.